looking at isosceles and equilateral. So before I even start the notes, isosceles, if you remember, hopefully you do, stands for two sides. Isosceles is two sides, or two sides are the same. And equilateral means all sides are the same. All right, so here if we have triangle ABC, in this case we can tell because this side and this side are marked the same. This is an isosceles triangle. The congruent sides of an isosceles triangle are its legs. And the third side is the base. With an E. All right, so if this side is the base, and the others are the legs. So the two that are the same are the legs. The third side is the base. The two congruent sides form the the vertex angle. So at the top, you're going to have a vertex angle. It's where the two congruent sides meet. And then the other two angles are the base angles. And that's where a leg meets the base. Kind of getting ahead of myself in the way I'm marking this, but notice I marked that the base angles are congruent because the sides are the same length. And that is basically the isosceles triangle theorem, which is this next thing we're looking at. If two sides of a triangle are congruent, then the angles opposite those sides are congruent. All right, so here we have, if these are the legs, if those are marked congruent, this says that the two sides opposite the angle. So from the side CB, across from CB would be angle A, and across from CA would be side B, angle B. So angle A is congruent to angle B. The base angles are congruent because they are across from the congruent sides. And that's the same thing I marked up here in the first diagram. Okay, so the converse of that is basically saying it in the other direction. It's going to say the same thing but in the other direction. So if two angles of a triangle are congruent, so A and B are congruent, then the sides opposite of the angles are congruent. So that means if you have two congruent angles, the side that is directly across from each are going to be congruent. So depending on what you have given to you, you can use either one of these theorems. So AC is congruent to BC. So if you're given the sides, then you know the angles are congruent. If you're given the angles, then you know the sides are congruent. And then a corollary is a statement that follows immediately from a theorem, so it's understood. Corollary to the isosceles triangle theorem. If a triangle is equilateral, then the triangle is equiangular. So just like if the congruent angles, the side across from the congruent angles is congruent. So if we have that third angle is also congruent, then the third side is also congruent. So equiangular triangles are always equilateral. Equilateral triangles are always equiangular. If it's one, then it's both. So angle A is congruent to angle B, is congruent to angle C, and we know what that measure must be. If we know that they are all the same, the only way they could all be the same is if you take the 180, you divide it evenly by 3, so we know that they are all 60 degrees. They can't be anything else. And we know that the sides are all the same if the angles are all the same. And then the corollary to the converse of the isosceles, again, we're just saying it backwards. If you know all the angles are the same, we could conclude that the sides are the same. Here, if we know all the sides are the same, we can conclude that the angles are the same. So if AC is congruent to BC, is congruent to AB, so all three sides are the same, then we can make the conclusion that all three angles are 60 degrees. So if a triangle is equiangular, then the triangle is equilateral. If a triangle is equilateral, then the triangle is equiangular. Those just always go together. And if it's equiangular, it's 60 degrees. The side length, well, never mind. I'm not going to say that. That might just be confusing. Okay, next page. The bisector of the vertex angle of an isosceles triangle is the perpendicular bisector of the base. Thank you. All right, so what that is saying is the bisector of the vertex angle. So we're going to take this one piece at a time. Bisector, we know bisector is a very special word. It doesn't mean it just splits the angle, but it splits it exactly in half, right? So here we have angle C is the vertex angle. We know that because the two sides are marked the same. So where the two congruent sides meet is the vertex angle. That's what I just went over on the other side. So I know that those two are the same. So if the bisector of a vertex angle of an isosceles triangle, it does have to be an isosceles triangle, is the perpendicular of the base, is the perpendicular bisector of the base. So perpendicular bisector means that it splits the base into two congruent pieces, and this is 90 degrees. Perpendicular means two lines meet at 90 degrees. Bisector means cut in half. So CD is perpendicular to AB, to segment AB, and CD bisects segment AB and angle C. There's only one blank there, and the blank was intended for the segment AB, but we could also say that it also bisects the angle, the vertex angle, angle C. And this is only isosceles triangles. All right, so find the value of each variable and the measure of each angle. That is quite a lot of examples. We're not going to do all of these. Okay. So here we have an isosceles triangle. You can see that because this side is the same as this side. All right, so what do we know about isosceles triangles? We know that the base angles are congruent. We know that this one is the same as this one. So if the one on the left is x degrees, then the one on the right is also x degrees. And this says that the one on the top is 3x. So if we have something for all three angles, and we know all angles have a sum of 180 degrees, which I like to write real big in the middle, all triangles have a sum of 180. If I add up what I have for those three, it's going to equal 180. So that gives me an equation. So I have x plus 3x equals 180, which is 5x, right? 5x equals 180. So if I divide that by 5, then I get that x equals 36 degrees. All right, so if I found out that x is 36, then I know that this one is 36 degrees. And I know that this one is 36 degrees. And I know that the one on the top is going to be 3 times 36 degrees. So that's 108 degrees. So I just found all three angles, even though only two things were marked, because I know that base angles of isosceles triangles are congruent, and I know that all triangles have a sum of 180 degrees. All right. So we got that one. Okay, so looking at the second one. Okay, it does show me. All right, so again, I have an isosceles triangle. Is this side the same as this side? So what do you know from isosceles? You know their base angles are congruent. So if this is 74, then I know that this is 74. And on the top, I see on the left it has one line, and on the right it has one line. So that means those two are equal. So that means this is a perpendicular bisector. It means that the vertex angle has been bisected, cut exactly in half. So the one on the left is y, and I know the one on the right is y. And we don't really need to know it for this problem, but I also know that makes 90 degrees down there at the bottom. And I know that this side length is the same as this side length. Again, that's not stuff we need to know for this problem, but I like to just mark everything that I know when I start working a problem. And what am I trying to find? It says find the value of each variable and the measure of each angle. Okay, so I could do this more than one way. Let's just say, I think the simplest way, I know all triangles are 180 degrees, right? So if total is 180. So 74 plus 74 plus 2y, right? Because I have two y's at the top. You know what, that's probably not the easiest way. That works, but I said I want to try for the easiest way. So the simplest way would say if I start with 180 and I subtract what I know, right? So I subtract 74, and then I subtract the other 74, the two base angles. That tells me I have 32 degrees left over. So I have 32 degrees left over for the third angle of the large triangle. That's a really ugly circle. So if this whole angle is 32 degrees and it's cut in half, I could say 32 and divide it by 2, right? And that would make each one of those 16. So y would be 16 and y would be 16. Now, the way I set it up the first time would also work, but this way I think is the simpler way of explaining it. All right, so the next example, you can see this is an equilateral triangle because there's three markings saying that they're congruent. 1, 2, and 3. And since this expression, 2x plus 32, has degrees on it, I know that's an angle, because that is not real clear where that's supposed to be. Kind of looks like it's talking about the side length, but it can't be because it says degrees. So I know that has to go to an angle because it's degrees. Degrees always talks about angles. All right, so if it's equilateral, then I also know it's equiangular. So this is the same as K, is the same as M. And I know that they're all 60 degrees because it's the only way to split up 180 degrees 3 ways evenly. All right, so if I want to solve for x, I know it's 60 degrees for angle L, and I know angle L is 2x plus 32. So 60 equals 2x plus 32. Subtract 32. So 28 equals 2x. And then divide by 2. So 14 equals x. And it said find the variable and the measure of each angle. Well, I already know all the angles are 60, so I don't really need the variable for anything else. That's it. Okay, let's see. Number B. The next example I can see is equiangular. These are all marked the same, right? So I know that those are all 60 degrees. And I know that equiangular triangles are also equilateral. So all the sides are the same. So the instructions were find the missing variable and the angles. I already have the angles. I do need the missing variable, but since all the sides are the same, I can say that 5y minus 6 equals 4y plus 12. And then solve for y. So I get the y's together, subtract 4y. Okay, so y minus 6 equals 12. If I add 6, then y equals 18. It did not ask me for the side lengths, so I don't really have to do that. If I wanted to, all I would need to do is plug y equals 18 into either one of the expressions because I know all the sides are the same length, and solve for one of them, and that's the length of all the sides. But it's not what I was asked to do. All right, so the next one is a little more complicated. Let's see, we have that the top is 90, because as that box for the whole thing is 90. And then I have on the left, I have an isosceles triangle, and I'm given the vertex angle. So it's isosceles. I know for isosceles triangles, the base angles are congruent. And if I have the top, I can figure out what the base angles are because all triangles add up to 180 and those are the same. So I could say 180 minus 50 is 130. And then I could divide that by 2. So each of those is going to be 65 degrees. So this is 65, and this is 65. I'm still not at x yet, but at least I'm on my way to knowing what all the angles are. I've solved for the angles in the small triangle. So looking at the top, at that vertex angle is 50, and I know the bigger angle that goes with that is 90. So if this part's 90 and that's 50, I could do 90 minus 50 is 40. So that means that this side over here has to be 40 degrees. And look, that's another isosceles triangle, because there's a line here and a line over here also. So two of the sides of this triangle are the same. So that means the base angles are the same, and the base angles are okay, so 40 is a base angle, and over here is another base angle, so that's 40. And now that I know the two base angles, I can find its vertex angle at the top, which is x, and that's the last thing I need. So if I start with 180, and I subtract 40, and subtract the other 40, that's 100. So I know that x is 100 degrees. So that one was kind of complicated, but as long as you keep in mind, if you look at one piece at a time, and mark what you know, finding the missing parts should be okay. And this one, again, is complicated. So I have sides marked the same, I have a 64 way at the top, I have an x way at the bottom. So since I know the 64, I'm going to start there. It's a good starting place. Start at the place where you know something. Alright, so I have that up here is 64 degrees. And I see this relationship is that X shape, the bow tie shape, vertical angles. So on the top is 64 degrees, then underneath it is also 64 degrees. So I could put a 64 right here. And now I'm into one of the triangles. So I can figure this triangle out because I have the vertex angle, and I see that it's marked as an isosceles triangle. I know isosceles triangles have congruent base angles. So to find out what the base angles are, I say 180, subtract the top one, minus 64, gives me 116, and I have to split it evenly between those two angles. So I divide by 2, and it's 58. So this one's 58 degrees, and this one is also 58 degrees. Alright, so I'm halfway through this figure. Again, I have a bow tie shape, so I know the other side is 58 degrees. Because vertical angles are congruent. And now I'm in the next triangle. I see it is also marked as an isosceles triangle. So that means its base angles are congruent. The base angles are across from the sides. So even if you're not sure, find a side, go across, that's 58. Find a side, go across, it's over here, that's 58 degrees also. That's the other base angle. Alright. There's two different ways I could finish this out. I could do it the same as I did the last one, where I start with 180, subtract 58 to find that missing the vertex angle. And then I would have a linear pair to find x. Or remember, whenever you have the piece that sticks off, that's an exterior angle. And an exterior angle is equal to the sum of its remote interior angles. So either way is fine. I'm going to go ahead and go with the 180 method. So if I say 180 minus 58, and then subtract another 58, that gives me 64. So this is 64 degrees. And then that makes a linear pair. Right here, it's a linear pair. And a linear pair is, they add up to make a straight line, right? It's a linear pair. Or you could look at the exterior angles theorem. But the linear pair is 180 minus 64, and that's 116. So that's x, 116. I know, very complicated problem. But really all I needed to know was isosceles triangles, and all triangles add up to 180 degrees. And vertical angles, you have to know vertical angles too. So just start at something like that. You would just start at where you know something. I knew 64 degrees at the top, so I started there and just kind of walked my way through to see what I could do. Okay, the last part of the notes. Complete the following and state the reason that justifies your conclusion. Angle WVS is congruent to what by what? All right, so WVS. First I need to find that. Here's W, here's V, here's S. So I'm talking about this angle right here. All right, so since I'm talking about that angle, that means I'm inside this triangle. I'm only looking, that's horrible, I don't like that at all. That means I'm looking at this triangle. And if I'm only looking at that triangle, I can see I have two sides marked the same. So I know the base angles are congruent. So if WVS is congruent to WSV by the Isosceles triangle theorem. Okay, and then the other one says TR is congruent to what? So I need to find TR. Here's T.
Maybe TS.
Yeah. So if I'm looking at TR, that means I'm looking at the large triangle. So TR would be congruent to TS. And since this is talking about the side lengths, this is going to be the converse, because I can see it's marked angle R and angle S. So by the converse, of Isosceles triangle theorem. Basically, this was just to, again, remind you, if you're using angles, it's the Isosceles triangle theorem. If you're using side lengths, it's the converse of the triangle theorem, Isosceles triangle theorem.